Very good morning to all of you. So, we are learning discrete mathematics, and today's topic is from Unit 5 related to trees, and specifically that too. What we are going to do is we are going to refer the exam question paper, and from that exam question paper, what are the frequently asked questions from this topic, trees. I have a pool of question papers here. From this I am extracting only related to tree questions like spanning trees there. Then again spanning tree, minimum spanning tree. Here we have to find out the minimum spanning tree using prims. So basically today it will be more on spanning tree, minimum spanning tree, and the two algorithms, Kruskal's and Prim's algorithm. So let us first see the exam question, define spanning tree. There is one more exam question, define minimum spanning tree. So let us try to recollect what is a spanning tree. Spanning tree is a graph, but spanning tree is a special tree in a graph such that the vertices of the graph are connected by some edges. Okay. So in a spanning tree, if the number of vertices are n, the number of edges will be n minus 1. When we are designing a spanning tree, we have to ensure that it is acyclic, meaning there should not be a cycle formed or there should not be a circle formed. So which spanning tree will be called as a minimum spanning tree? The one with the minimum weight, Let us first see the Kruskal's algorithm, then we'll go for the Prim's algorithm. Basically, these are the two algorithms which are referred. One is the Kruskal's algorithm for finding minimum spanning tree, and the other one is Prim's algorithm. We'll directly refer the example to find the minimum spanning tree using Kruskal algorithm for this graph. Okay. Let us see this graph and let us see how many vertices are there in this graph. The vertices are A, B, C, D. So total number of vertices are 4. If we design a minimum spanning tree for this graph, the number of edges will be 4 minus 1. So the number of edges should be 3. Now, let us also remember what is a minimum spanning tree. Minimum spanning tree is a spanning tree with minimum weight. It will be connecting all the vertices and it will be acyclic. So, the first step in Kruskal's algorithm, is remove loops. So, we need to check where are the loops in this graph. A node is there, there is a loop. D node is there, there is a loop with weight 8 and 4. So, these two loops are removed. So, you can see in this diagram, the second diagram, here the loops are not there at the node A and B. The second step is remove parallel edges with higher weights. As you can see in this graph, you have A and C nodes which are having parallel edges. The weights are 2 and 12. So, what the step is telling us? The step is telling us to remove the parallel edge with higher weight. So, 12 is the edge with higher weight. So, we will be removing this 12. So, now the new graph will be like this, where you don't have loops and where you don't have the parallel edges. Okay. After that, what is the next step? You have to create an edge table. Such that you start with the lowest weight and you go on increasing till the end. So, look at this graph now, and in this graph you can easily identify which edge is having the lowest weight. Okay. So, you can see here BC is the edge with lowest weight 1, then AB is the edge with weight 2, then AC is the edge with weight 2, then CD is the edge with weight 3, BD is the edge with weight 5. So we have identified, taken all the edges 1, 2, 3, 4, 5 and in their increasing order of weights. Now the minimum spanning tree will be having how many number of edges? The minimum spanning tree will be having 3 edges. So we have to pick 3 edges from this edge table and they should be like minimal. So you can directly pick up BC. So this BC will be 1 edge. Then go for the next edge AB. AB will be 1 edge. Then go for AC. But can I go for AC? I cannot go for AC because BC, AB, AC will be forming a cycle. So then go for the next one CD. So first edge is selected is with weight 1 BC. Second edge is selected is AB with weight 2 and the third edge selected is CD with weight 3. So this will be our minimum spanning tree: BC with weight 1, AB with weight 2, CD with weight 3. CD with weight 3. So this is how you will be using Kruskal's algorithm to find out the minimum spanning tree. There are few more examples. You can see here in this graph you don't have any loops, you don't have any parallel edges. So directly prepare the edge table. So in the edge table again you go for AB, then BD, then DC, then BC, then AC. Then how many vertices are there? 4 vertices. How many edges will be there? 3 edges. Which one will we keep picking up? Then AB I can pick up, then BD I can pick up, then DC I can pick up and stop there itself. Here also, do we have any loops? No. Do we have any parallel edges? No. So prepare the edge table in the increasing order of their weights. As the number of vertices are 6, the number of edges will be 5. The number of edges will be 5. So you can go for AD, then BC, then DC, then EF. Then I cannot go for AB because it will form a cycle. Can I go for BD? For that I need to check BC I have selected. Yeah, I can go for BD also. So 1, 2, 3. AB I am not going. 4. Okay, BD. This much I think. Yeah. But have I selected BD? No. Have I selected BD? No. So it means I have selected AB. No. I have not selected. I have gone for AD, BC, CD, CF and EF with total weight 9. So same thing here. Just as there are no loops, as there are no parallel edges, go for the edge table in the increasing order of the weights. Vertices -1 will be the edges. So let us go for the next algorithm, which is Prim's algorithm. There are two ways rather, though they are similar, a little subtle difference you can find out. The next algorithm for finding the minimum spanning tree is Prim's algorithm. What you have to do in Prim's algorithm, you have to randomly select a vertex, pick any vertex. Then you find the total weight of that vertex, start with that vertex, find the total weight of that vertex. For example, A, the total weight is 13, then B, the total weight is 16. So like that you list out the total weights. Same thing, whatever vertex you had selected, you pick the edges related to that in such a way that the total weight and the weight will be less. So, and this way you will be designing your the minimum spanning tree. There is one more example with a subtle difference. Let us look at that example too, using Prim's algorithm. Again, this is an exam question. What is the exam question? I'll read out the exam question. Define a minimum spanning tree from the given weighted graph by Prim's algorithm. So this is my graph. Let us look at my graph and see how many vertices are there. 1, 2, 3, 4, 5. So total 5 vertices are there. In my minimum spanning tree, how many edges will be there? Edges will be 4. Edges will be 4. Now, this Prim's algorithm says what? Randomly select a vertex. Randomly select a vertex. After that, select a connected vertex to that vertex which is minimum, which is having minimum weight. Repeat. While repeating this procedure, also consider the left out vertices with their weights and check if in future they will be useful if their comparative weights are less. While doing this, you have to ensure that no cycle is formed. Okay, so let us see how it goes. Okay, so this is my graph now. As you can see, the number of vertices are 5. So the number of edges should be 4 in the minimum spanning tree. So I have randomly picked up vertex 5. I have randomly picked up vertex 5. So when I picked up vertex 5, I know that it is connected to V1, V2 and V4 through 5, 3 and 2. So you have, it is not actually 5, but assuming it is, if it is 5, no, it is not actually 3, 5, it is 3, consider 3 only. So we have V5 connected to V1 through 3, V5 connected to V2 3 weight and V5 connected to V4 to 2. So which one is the lowest? Weight 2 is the lowest, so go for V4. So I have connected V5 and V4 and 2. Now which are the not considered weights? 3 and 3 are the not considered weight, which I have to remember. Now V4 is connected to V5 with weight 2. Let us check V4's connectivity with other vertices and their weights. V4 to V1 3, V4 to V2 1, V4 to V3 3. So among this I know that the one with weight 1 I have to pick up. So I will go for V4 to V2. I will go for V4 to V2 with weight 1, with weight 1. Now again V2 is connected to V1, V5, V4 and V3 with 4, 3, 1, 2, 4, 3, 1, 2. Already one is selected between V4 and V2. So 4, 3 and 2, 4, 3 and 2. Now I also have left out edges like this 3 and 3 are left out, this 3 and 3 are left out. Here I have the option for V2 is 4, 3 and 2. So I will go for 2 lowest. I will go for 2 lowest. So V2 to V3 I will connect with this lowest. V2 to V3 I will connect. Now from V3 what is possible? From V3 3, 3 is possible. So I have now 3, 3 left out 3, 3. So I have all of them are 3, all the contenders are with weight 3. So I am picking up anyone randomly. I have picked up V1, so with 3. I am counting the number of edges now 1, 2, 3, 4. So the number of edges are 4. This is my minimum spanning tree. So and the total weight is 8. The total weight is 8. So I am just checking if anything more is there. Yeah. The time complexity is O of E log E. So here the definition again. What is a spanning tree of a graph? That has all the vertices of the graph connected by some edges. If the vertices are n, in a spanning tree the edges are n minus 1. The minimum spanning tree has minimum weight. Minimum spanning tree has minimum weight. There is one more exam question. List out the properties where graph possesses to qualify as a tree. So I just need to give the definition of a tree because tree is derived from graph. That will suffice the answer for this question. What we have written, what is a tree? It's a connected undirected graph. What is a tree? It does not have any circuit. Okay. So for example, this graph is not a tree because it is forming a cycle. So if the degree of a vertex in a tree is 1, that will be terminal node. If there is a collection of disjoint trees, it is called as forest. So a graph will be called as tree if and only if there is a unique path between every two vertices. A graph is a tree if it is connected and it has exactly n minus 1 edges. In this graph, we have pendants A, D, H, I, K. You know the meaning of pendant? Degree is 1. In a tree, there are sets of at least 2 vertices. There will be 2 vertices in a tree with at least with degree 1. So this will suffice the answer for this question. So thank you.